everybody, and welcome to Chapter 6. We're going to talk about elasticity, or how responsive prices are to changes in demand. So we're going to start off with the price elasticity of demand. We'll also look at the price elasticity of supply as well. It's not just demand. We're going to look at what's known as the total revenue test, determinants of price elasticity of demand, and cross elasticity and income elasticity of demand. So the price elasticity of demand is the following. It measures buyers' responsiveness to price changes. By rule, remember the law of demand tells us that as a price goes down, demand will go up, and as a price goes up, demand will go down. But depending on how much it changes depends on how elastic a product is. Something with elastic demand is highly sensitive to price changes. So think of something like Coca-Cola. You can easily substitute Coca-Cola for many other sodas and other soft drinks, so if Coca-Cola tripled in price, it's probably going to lose a ton of its demand. People will buy Pepsi or store brand cola or Gatorade or any of the many substitutes. And you'll have large changes in the quantity demanded based on price. Something with an inelastic demand is still going to lose demand as price goes up, but to much less of a degree. Think of something like gasoline. Gasoline is really pretty insensitive to price changes. As much as we may grumble when gasoline gets very expensive, when given the choice between not being able to drive to school or work or being able to drive to school or work, as a consequence, we're going to have to buy the gasoline. So as a consequence, there's only a small change in the quantity demanded. People will cut some unnecessary trips if gas was $5 a gallon, but you're not going to see huge changes in demand, whereas if Coca-Cola tripled in price, their sales would fall off a cliff. So as for the price elasticity coefficient, how can we calculate it? Well, the percentage change in the amount demanded divided by the percentage change in the price, and that will give us ED, or a measure of elasticity. So that's one way to calculate it. Another way is using the midpoint formula. So to do this one, change in quantity divided by the sum of quantities over 2 divided by the change in price over the sum of prices divided by 2. Using traditional calculations, measured elasticity over a given range of prices is sensitive to whether one starts at the higher price and goes down or starts at the lower price and goes up. The midpoint formula calculates the average elasticity over a range of prices to avoid that problem. So that's why we might use the midpoint formula. So the price elasticity of demand formula, generally we use percentages. Why? Because it's a unit-free measure and we can compare elasticities. So change depends on the choice of units. So the change of a $10,000 car by $1 is very different than a $1 can of beer by $1. The car is changing by a small fraction of a percent, whereas the beer would be going up or down by 100%. So percentages also make it possible to compare elasticity for different products. So we make everything a percent, and also we eliminate the minus sign. So because of the inverse relationship between price and quantity demanded, elasticity of demand is going to be a negative number. We get rid of the negative sign. We just look at the percentage. They're all going to be negative, therefore we just make them all positive as a consequence. So if ED is greater than 1, you would say you have elastic demand. If ED is under 1, you would say you have inelastic demand. And if it equals 1, you would have what's called unit elastic demand. What that means is a percentage change in price and the change in demand are exactly equal. So if price goes up by 10%, demand would go down by 10% if it is unit elastic. ED equals 0 would be perfectly inelastic demand, and ED equals infinity would be ED equals 0 is perfectly inelastic, meaning the price could be anything and demand doesn't change, and ED equaling infinity is it's perfectly elastic. You're never going to get perfect elastic or perfect inelastic demand in the real world, but that's what it would mean. So perfectly inelastic means consumers will buy the same amount no matter what the price. Perfectly elastic means nothing will be purchased if there's any change from the current price. So perfectly inelastic demand, what we were just looking at, would look like this. It would just be a vertical line No matter what the price is, quantity doesn't change. Perfectly elastic would be a horizontal line, no matter what there's only one price. If the price changes in any other way, there would be no demand. So a small price reduction would cause buyers to increase their purchases from 0 to all that's possible to obtain. That's perfectly elastic. It's a horizontal line, and it would be infinite. An example of perfectly elastic demand is a firm's demand curve in a purely competitive industry where you can't change the price. If you have perfect competition and everybody's pricing at the same thing, you can't change the price as a consequence. So what is total revenue? And total revenue is the easiest way to judge if you have elastic or inelastic demand. And total revenue is simply price of whatever product or service we're interested in, multiplying its quantity. So we can do what's called the total revenue test. If we have elastic demand, price and total revenue are going to move in opposite directions. So if demand's elastic, price is going to move in the opposite direction of revenue. If you have inelastic demand, price and revenue will move in the same. If something's very inelastic, you can raise the price and demand's not going to change very much, so revenue will go up. Whereas something like Coca-Cola, if they multiplied their price by 10, it would actually decrease their revenue because they really wouldn't sell anything anymore. And if something's unit elastic, total revenue won't change when price changes because they're moving in lockstep. So here's what it would look like with elastic demand, so lower price and elastic demand. Your blue gain would exceed your yellow loss. So even though price is going down, quantity is going up. So it's cheaper, but you're selling so much more, your revenue actually went up. If we look with inelastic demand, yellow loss is going to exceed the blue gain. So in this case, even though we reduced the price, demand didn't change very much, and as a consequence, our revenue is a lot less. Originally, it was 10 times 4. Now it's only 20 times 1. And with unit elastic demand, the gain and the loss will be exactly the same because they're moving in lockstep. As we drop the price, demand will go up and it'll move in the exact same amount, and as a consequence, revenue will not change. So here's an example of a total revenue test. So in the high price region, demand for movie tickets is elastic and revenues increase as price falls. Midway, it becomes unit elastic and revenues stay the same as price falls. And in the low price region, it becomes inelastic. Eventually the movie tickets get so cheap that it really becomes pretty inelastic and revenues fall as the price falls. So the first graph shows the relationship between price elasticity of demand for movie tickets and total revenue. And demand curve D is based on the table at the top. And it's showing the hypothetical weekly demand for movie tickets is elastic at high prices and inelastic at low ones. And the total revenue curve is being derived from the demand curve. So when price falls and revenue increases, demand is going to be elastic, as we see at the beginning. When it falls and it's unchanged, it becomes unit elastic in the center, the light green bar, or what I'm about to highlight for you right here. And when it falls and revenue declines, it becomes inelastic, as we see here. So in this case, we have all three situations depending on the price. We go from elastic to unit elastic to inelastic. So once again, greater than 1, it's elastic or relatively elastic, and quantity demanded changes by a larger percent than price. And here's what happens. You increase price, revenue decreases. You decrease price, it increases. When it's unit elastic, it's unchanged. No matter what you do to the price, revenue won't change. And quantity demanded changes by the same amount as the price does. And that's when ED is 1. And when it's inelastic, quantity demanded changes by a smaller percentage of the price. So if you increase the price, you're going to get more revenue. If you decrease them, less. So what actually determines how elastic something is? We already used gasoline as an example. And gasoline has two things. Number one, substitutability. The more substitutes you have, my first example was Coca-Cola, And Coca-Cola has an absolutely tremendous amount of substitutes. You can substitute it with juice or Gatorade or other sodas or water or seltzer or anything like that. There are many, many different soft drinks. Many other types of colas that taste broadly the same. So Coca-Cola is highly substitutable. Gasoline really isn't substitutable at all. You may have a car that can run on alternative fuels like flex fuel, so in that case you might be able to substitute it a bit. But for the most part, if your car runs on gas, you can't substitute it for some other kind of fuel. Your car is not going to run on diesel or anything like that. So as a consequence, that's why it's very inelastic. As for proportion of income, the higher the proportion of income a product or service is, the more elastic demand. If something changes from $1 to $2, it's probably not going to have that much of an effect on demand, for the reason being that's not a very high proportion of your income. But if a car went up by $10,000 in price over a month, it would have a much larger impact on elasticity. It's a higher proportion of income. As for time, so luxury versus necessities, luxury goods have much more elastic demand. Things like staple food items or gasoline, they're very inelastic. Whereas a luxury item like caviar or expensive steaks or something, much more elastic in demand. If they get more expensive, you can cut them out pretty easily. But staples like chopped meat and pasta and tomato sauce, those are going to be a lot less elastic. And as for time, the more time available, demand is more elastic. So it takes time to alter the amount being purchased, so the more time available, the more elastic. Someone doing their Christmas shopping on Christmas Eve has very inelastic demand because you simply don't have the time to shop around. Whereas if you start your Christmas shopping 2 months early, you can shop for the best deals. So the more time you have, the more elastic your demand. If you need something tomorrow, it's an absolute necessity, you have to get something tomorrow, you're going to be very inelastic. And here are various things, ranging from things which are highly, highly, highly elastic to things which are very inelastic. So things like, here are your most elastic stuff here. Luxury china, residential land, restaurant meals, expensive cuts of meat, fresh fruit, fresh peas in this case. Whereas things, gasoline is right here, 0.58. And some things are pretty surprising. So Major League Baseball tickets are highly inelastic. A lot of them are purchased as season tickets, and fans are pretty much willing to pay whatever. Some items aren't very shocking, things like cigarettes, sugar, eggs, car repairs. The more necessity, or in the case of cigarettes, the more addicting the product, the less elastic it is going to be. Whereas something easily substitutable like lamb and mutton or china glassware or something like that will be a lot more elastic. Cars are over 1.1. They are elastic. Cars are pretty sensitive to the change of price. The car industry has changed quite a bit since COVID, so I'm curious if these numbers still hold up. They are from probably a couple years old at this point, but this is just a selection of various things. So what are some applications? If you have a lot of crop yield, so let's say we have a great bumper crop of corn, you're going to wind up in a sense where the supply of crops increases and shifts to the right and price falls. Demand for a lot of crops is pretty inelastic, so the lower price actually leads to lower revenue, and farmers are generally worse off when there's a larger yield of staple crops like corn or potatoes or something like that because of how inelastic they are. As for taxes, generally the government, if they want to tax various products, they're better off taxing things that are inelastic, so they'll get a lot of revenue from those taxes. If they tax something that's really elastic and raise the price, a lot of people are going to not buy that product anymore, and they won't actually make the tax revenue. So what about things like decriminalization of drugs? Marijuana legalization is very common now. So demand for drugs are generally pretty inelastic. So as a consequence, you can make this argument for all sorts of drugs. So since demand for them is inelastic, if they were legalized or decriminalized and the price went down, the amount consumed really wouldn't change very much, and you would also get less crime and illegal black market drug dealing and all of that stuff. And that's the argument behind most of the decriminalization and legalization pushes now. That and tax revenue as well, which once again, if you're going to tax something that's inelastic, and it's been highly successful with things like legal marijuana, whereas people will happily pay the tax to be able to buy marijuana legally. As for price elasticity of supply, once again, this is going to measure sellers' responsiveness for price changes. So we looked at demand, now we're going to look at supply. Elastic supply means producers are really responsive to price changes. So if price goes up, they're going to supply a lot more. If price goes down, they're going to supply a lot less. Whereas an inelastic supply, they're really not going to change very much what they supply based on the price. So elasticity of supply is the percent change in quantity supplied of a product divided by the percent change in its price. That's elasticity of supply, or ES. We already looked at ED. We're now going to look at ES. And price elasticity of supply, once again, greater than 1, it's elastic, equal to 1, unit elastic, so a 1-to-1 relationship, less than 1, inelastic. And if it's 0, it's perfectly inelastic. And we'll take a look at that as well. So elasticity of supply is generally determined by time. And we're going to look at 3 periods. And if you took macro with me or any other professor, you would have covered this. Remember, when we consider supply, we look at intermediate market period, short run, and long run. So very short run, long run. So the ease of shifting resources between alternative uses is very important in elasticity of supply, because it's going to determine how much flexibility a producer has to adjust its output to a change in the price. The degree of flexibility and therefore the time period will be different in different industries. So the immediate market period means that there is no time to adjust output in response to a price change. And some industries may not have an immediate market period if they are able to store their product. The short run means that there is enough time to adjust output by increasing or decreasing the inputs that are variable, but not the fixed ones, so like your labor cost and stuff like that. But remember, in a long enough amount of time, everything can change, including your labor costs or fixed costs. So in the immediate market, you have perfectly inelastic supply because everything's generally locked in. So sellers can't really adjust to a price change at the very beginning, so supply is perfectly inelastic. With a perfectly inelastic supply, the increase in demand does not change the quantity demanded. So even though demand went up, there's no change in supply, so as a consequence, price is going to go up in the immediate term. Now in the short run, which is a longer amount of time, it becomes more elastic. So supply can change. So there's enough time to adjust output by increasing or decreasing your variable inputs, but not the fixed ones. So supply is more elastic in the short run than the immediate market, so we can increase quantity as we see here. Demand is increasing. Quantity, we're moving along the supply curve from Q0 to QS. Price is still going up, but to less of a degree, and we have more supply. Now, in a long amount of time, we can change everything. So in a long enough amount of time, we can adjust output by increasing or decreasing all inputs, including the fixed in place ones at the beginning. And this means that supply will be even more elastic, and with the same increase in demand, we're going to get an even larger increase in supply than the short run. And remember, in a long enough amount of time, all your inputs are variable. Even the size of a company, companies can increase their size or decrease their size. So everything can change in a long enough amount of time, and we get a larger increase in supply. So what are some applications of the elasticity of supply? So something like antiques, there's an inelastic supply because you can't make more of them. An antique is something that's finite. So as a consequence, so for one-of-a-kind antiques or rare art or something, the supply is perfectly inelastic. What's left is left. And it makes their price highly susceptible to fluctuations in demand. Think of vintage cars. They were not making more 1965 Corvettes, but if the demand for them goes up, the price is going to go up. The supply that's left is what's left. So the more inelastic the supply, the greater the change in price when demand changes. So think of some vintage product which got very popular again, so various models of old cars or old furniture or something like that. You're going to see huge changes in price. Things like reproductions of antiques are much more elastic. So if 1960s furniture comes back, companies will start making furniture that looks a lot like the furniture from the 60s, and this will be much more elastic in supply. They can make more of it, whereas actual furniture from the 60s, what is left is what's left. And things like gold prices. Gold has got a highly inelastic supply as well, so as a consequence, prices can jump all over the place. People speculate and invest in gold, and once again, much more inelastic supply than something like reproductions of antiques. So consumption of a good can also be affected by a change in the price of a related one. So let's say computers triple in price. It's going to probably hurt the demand for things like flash drives and wireless keyboards and all webcams and all of the things we use with computers. And that's what we mean by cross elasticity. So the percentage change in the quantity demanded of product X over the percentage change in the price of product Y, that would give us the cross elasticity, or EXY. So if we wanted to know the cross elasticity of webcams, we would go with the change in webcam demand up top divided by the change in the price of computers. If you don't have a computer, you're not really going to have any use for a webcam. So cross elasticity of demand measures the responsiveness of purchases of one good to change in the price of another. Generally, if it's positive, so if goods are substitutes, they're generally going to have a positive cross elasticity, since the change in one is going to, and the change in demand for its substitute, move in the same direction. So if Coca-Cola gets more expensive, Pepsi's demand is going to go up. They would be positive. If the goods are complements, such as computers and webcams, it would be negative, because if computers get really expensive, demand for webcams is going to drop. If they're unrelated, it will have a cross elasticity of 0. There's no cross elasticity between Toyota Camrys and Coca-Cola, for instance. They have nothing to do with each other. If Coca-Cola gets more expensive, it's going to have absolutely nothing to do with the demand for a new Toyota Camry. Whereas if computers get more expensive, it will have something to do with the demand for webcams. And if Coke gets more expensive, Pepsi's demand is going to go up. So what are some applications? Well, should a company change a price, and also should the government allow a merger? So companies use cross-price elasticity to determine if raising the price of one of their products will affect the sales of another. So companies make both computers and webcams. If they make their computers more expensive, is it going to really hurt their webcam sales? That they're going to make those predictions. And also, should the government allow a merger? If there's a high cross-price elasticity, the government may not allow it. So the government may not allow a company to buy up its biggest competitor. And that's something that is often in the news when we look at corporate mergers. So here are some examples. Cross-elasticity of demand between education spending and increases in the price of food. So the amount by which education spending falls and food prices go up is higher in low-income countries than in the higher ones. And that's what we're looking at here. So what is income elasticity of demand? Well, consumption of a good can also be affected by a change in income. Income elasticity of demand is a measurement that reflects the percent of change in quantity demanded due to some percentage change in consumer income. So as your income is changing, the change in demand is recorded as well, and we can get elasticity for income of demand. And it measures the responsiveness of buyers to changes in their income. If it's positive, we're looking at what are known as normal goods. Normal goods are your brand names, the goods that you want to buy. Whereas inferior goods are cheap substitutes. A normal good would be Coca-Cola, the store brand would be inferior. A normal good would be an iPhone or a Galaxy. Some cheap Chinese clone of one that you buy on Amazon would be an inferior good. So inferior goods generally have a negative income elasticity of demand, meaning as people's incomes go up, they don't want cheap substitutes anymore. Normal goods have a positive one. As someone's income goes up, they're going to buy more of the brand names, more of the better products. So some insights: high income elasticities, those are generally most affected by recession. So something like Louis Vuitton belts or really expensive luxury goods. If we're in a severe recession and people's incomes get hammered, they're probably going to be some of the first products to go for a lot of people. It's not something you need. Whereas something like Coca-Cola or brand name gasoline or the brands of clothes you like, so your sneakers or your jeans or something like that, they're going to be a lot less affected by recessions. Very high-end luxury really gets hammered. So something with lower negative income elasticity, not affected by a recession. Staple products, food products, stuff like that. So if we look here for cross elasticity, if it's positive, the quantity demanded changes in the same direction as the price of the other one, so that's your Coke and Pepsi, and those are substitutes. If it's negative, it's your computers and your webcams. They're going opposite directions. As for income, if it's positive, you're dealing with normal or superior goods, your brand names. Income goes up, more demand for the brand name products. If it's negative, you're dealing with inferior goods. Income goes up, less demand for the cheap knockoffs. And here's the income elasticity of demand for gasoline, and it varies widely across countries, and it's larger in your lower income ones. In something like the United States, it's fairly inelastic. Even though demand does change when gas gets very expensive, for the most part, we're still going to fill up to go to work and school and all of that stuff. And that brings us to our last slide for the chapter. Why different consumers pay different prices. So some firms have power that allows them to set their products at prices in their best interests. So for some goods and services, firms may find it advantageous to determine differences in elasticity and then charge different prices to different buyers. So business air travelers have a much more inelastic demand than regular consumers. So generally, they're charged higher prices. Business and first class are generally a lot more expensive because they're willing to pay it. Whereas regular tourists and families are much more sensitive. So generally, coach airfare is going to be a lot cheaper and as a consequence, a lot more elastic in demand. Coach flyers generally cross-shop airlines, and if one is 3 times the price of the other, they'll generally go with the other airline, whereas business travelers generally become loyal to one airline that they get perks with, and they're really not very sensitive to price changes. Their company picks up the tab for the most part, and that's the difference. Students from low-income households are generally offered tuition assistance, paying for college, where higher income ones generally will pay full price. And that's another example as well. So there are situations where different consumers can pay different prices, and that's all due to elasticity. And that's going to take us to the end of this chapter pertaining to elasticity.